Okay, so in number 2, we're still going to find the average rate of change, which you know already is a fancy way to say the slope. So start there. M equals, we know it's y2 minus y1 over x2 minus x1. So just for the sake of organization, x1, y1, x2, y2 above our 2 coordinate points there. So we've got k of x equals x squared plus 4. That's our function. So in the setup here, k, let me get k out, k of m plus h minus k of m, right, y2 minus y1, there we are, divided by that quantity m plus h minus m. So those are our x values we're subtracting. Okay, so moving forward, k of m plus h, what does that mean to do? Well, that's a function, right? Function notation means you need to provide an input. Let's input something into the function. So that thing we're inputting here is m plus h. That's going to go in for our x in this x squared plus 4. So I'm going to write it with parentheses here. So inside here, x squared plus 4. And notice I just left the x squared blank because we're actually going to input, right? Function means input, and that's where we put our m plus h. Okay, so that's actually taken care of. M plus h squared, that quantity squared, plus 4. And now, going forward, let's see, minus k of m, that part right there. Minus k of m. So, basically, all we do is take the m and plug it in for x, right? A little bit easier. Instead of x squared plus 4, it's going to be m squared plus 4. So, put parentheses for that too. Those are actually going to be critical, these parentheses here. X squared plus 4. Again, I write it, and I leave the x blank because I'm going to plug something in, that thing being m. Okay, the denominator, we have m plus h minus m. So you see it. You probably noticed the pattern if you've done enough of these so far. That term and that term, the m's on the outsides, they're going to cancel. We just get h in the denominator. All right, so going forward from there, got an h down here. On top, what math do we have left to do? Well, we've got m plus h squared. And don't make the mistake of saying that's m squared plus h squared. That's not what that is, right? Technically, you should have to FOIL that out, like m plus h times m plus h. Okay, so to be fair, let's multiply that all out. And I'm not going to FOIL it. We're going to talk about the pattern for squaring a binomial. And that pattern is this. So square the first term, the term being m. So m squared. Multiply the two terms together, m and h. So that's m times h, and I need you to double that. So that happens twice. mh, so double mh, that's 2mh. And then square the last term, so that's h squared. Okay, and then you can't forget about this. There's still a plus 4 over here. So even though we squared this term already, there's still a plus 4 over here, so make sure that plus 4 finds its way down here too. So plus 4. And then, so that's been evaluated. We got a negative here, so that's why it's critical that we have these parentheses. Otherwise, you would probably forget to make sure this negative hits this m squared and this 4. So let's go ahead and make that negative distribute to both of those terms. So minus m squared minus 4. And now how are we looking? Well, things that cancel. M squared minus m squared, see you later. 4 minus 4, see you later. All we've got left is 2mh plus h squared all over h. So if you haven't noticed by now, things really simplify in these problems. In fact, when we get done, there won't be an h in the denominator anymore. That should eliminate also. So what happens now? If a lot of people think at this point, you just cancel the h, cancel the h, cancel the h, and that's totally fine. If that's you, and you get the answer correct, totally fine. And the other way to go about it is, let's think about just factoring the top of that fraction there. So what factors out on the top? So 2mh plus h squared, right? GCF, you could take an h out of both of those. So if I took an h out of both of those, I would just get 2m plus h. And now you'll notice, like, okay, so on top I have an h, on bottom I have an h, that's where you have your cancellation. So to stay consistent, we could have just factored it out on top. My final answer here, 2m plus h.